we're going to continue on from the theme of the day. One of the things that many companies are trying to do is move work offsite and leverage standard products. And one of the hope or the belief is that whenever we talk about applying operation science to construction, they say, well, manufacturing is easy because all they do is mass manufacturing of standard products. However, you'll be very surprised how many different variations of quote-unquote products they're actually making and what it takes to run a manufacturing operation. Because a lot of them are now faced with dealing with low volume, high mix. And the variability they see is a lot greater than construction, you'd be surprised. And to actually take us through that, what it means to apply operation science in a dynamic, high mix, low environment, we have invited Pedro and Wes from TD Williamson. Please come and join the stage. As I introduce you, Pedro is the Senior Director of Global Quality and Operations Excellence at TD Williamson. He is responsible for building and strengthening product and services delivery system. And Wes is a process innovations manager at TD Williamson. And prior to that, he was an application analyst and mechanical engineer at a company. Okay? So take it away.
Thank you, James. Appreciate the introduction and the warm welcome. I lead the TD Williamson Global Operational Excellence team, and I'm also responsible for a charge, and that is to transform our global manufacturing operations across the globe. And we're going to do that consistent with an operations-based science approach. Okay. Wesley Glenn is our principal operations science practitioner, and he's also our factory physics modeler. We've talked a lot about modeling. We also use the model to help us in what we're trying to achieve as well. He's also our process design engineer. Wes and I will be co-presenting application of operation science in a dynamic, high-mix, low-volume environment. We have quite a bit of information that we want to convey and share with the group here, and so we want to really be mindful of the time so that we can cover everything, including a question and answer session there towards the end. We thought that to this end, a journey-type storytelling approach would be instrumental, and so we've got a slide here that we're going to be covering, and we think that this slide helps us provide the right amount of context for the journey that we've embarked upon, trying to employ all of these operations-based science approaches in this unique manufacturing environment that we're in. So I'm going to briefly cover mile markers, or the milestones, 1 through 4, and then I'm going to hand it over to Wes, who's going to walk us through in detail, because we believe that that's the crux of what we want to try to convey today, is the experience that we came across when we were traversing mile markers 5 through 7. Okay, there's quite a bit of information that he's going to share with that, and then what we'll do is we'll come back. He'll turn it back over to me, and I'll briefly update where we stand on the rest of the journey. TD Williamson has been a family-owned business for over 100 years. That's saying a lot if you stop and you think about it. I mean, how many companies have been around for 50 years? That's a heck of an accomplishment. And how many have gone, away after 50 years? So 100 years is really a significant accomplishment. The business that we're going to be focused on, that we're going to be talking about, is TD Williamson's hot tapping and plugging business. We provide goods and services to pipeline operators so that they can keep it in the pipe, keep production flowing, and it's vitally essential to any country's national infrastructure. The HTMP business essentially produces 5 things. It's 5 products that we put out when you boil it down to its essence, and they are as follows. We manufacture tapping machines, okay? We manufacture We manufacture isolation valves that are used along with those tapping machines, the isolation fittings that are required to do those interventions, housings and adapters. That's it. At the highest level, five products is what we produce, okay? They say that the one constant in life is change. And in July 2022, the winds of change blew at TD Williamson because a private equity firm out of Houston decided that they were going to take a majority stake in TD Williamson. So after 100 years, TD Williamson is now majority owned by a private equity firm outside of out of Houston. With the acquisition came a challenge for TDW, and that was to increase the throughput across the global manufacturing footprint. So that was the challenge that was set. And to meet that throughput challenge, my recommendation was not single piece work, because we knew that was not going to be the answer for our manufacturing environment. Previous attempts at trying to implement a lot of the Toyota production system, those standard offerings, mass producing them, they just were not going to work in our environment. So my recommendation to the leadership and to the private equity firm was that we pursue an operation science-based approach. Okay. All right, so what I'm going to do is here, very quickly, I'm going to walk you through the first three mile markers here on the journey map. So I've indicated that back in July of 2022, the acquisition was made, the edict was given, the mandate, we're going to increase throughput, and that gave rise to us working very closely with the factory physics folks. And what we ended up doing was convincing the organization that we can employ factory physics and the operation science-based approach as a demonstration to prove out the concepts. We had our fittings lineup. We were struggling at the time with lead times that were something on the order of about 7 weeks. The market really required them to be 3 weeks. And so we took on the challenge, and probably inside of, I want to say, less than 4 months, we went ahead, started working very closely with Dr. Chu and the team, and we started to model the flow through the plant for large diameter fittings. And what we found was a number of things. Number one is what we found was the working process that we had out on the shop floor at any given times was about 4 times what it was required to be. And that was driving up cycle times as a result. The other thing that we found is we discovered that we had all kinds of inventory just sitting out in places that was also driving up our cycle times. So we went to work, we designed a constant working process, CONWIP. It's a form of whip control. And we started to control how much work we would release out on the shop floor. We started to slowly drain the inventory that we had in the system, and as we were doing that, we were monitoring it, and what we observed is that things were starting to flow. Long story short, at the end of about 4 months, we got to the point where we were on average producing something like less than 1 fitting per day, and at the end of those 4 months, we were producing something on the order of about 4 fittings per day. We got the lead times down to 3 weeks, and our on-time delivery performance to those 3 weeks lead time, published lead times, was on average 2 weeks. So it was a resounding success. We were then asked to expand the concept to another part of the portfolio, our DS equipment. Here it's a little bit more complicated because the DS equipment, has on average, when you blow up the bill of material, it's got something like between 50 and 70 line items when you blow up the bill of material. So the complexity ended up increasing as a result. But we took on the challenge. We followed the same process. We modeled all of the part numbers through the C-suite model. We identified where all of the work centers that were highly utilized. So we identified where the constraints were. And then we started working on designing constant working process, or CONWIP, and started putting in place the whip control. And what we found is that as we started to do those things and we started to lower the working process, we got the flow that we were looking for. And there again, more resounding success. However, what we discovered was that as we started to expand the product portfolio onto this new mode of operation, we started running into issues with the old mode of operation. So we had one foot in the new mode of operation where we're controlling work in process for large diameter fittings, for the DS equipment with good success, but because there is so much overlap in the plant, we've got 52 work centers, and the remainder of the product portfolio was being managed through a traditional push type system. So we started to see where there were conflicts that were starting to arrive. So we arrived at a decision point, and that's mile marker number 3, I believe, and that was, okay, a decision point around how do we end up getting the entire plant on CONWIP. The remaining mile markers, 4 through 7, Wes is going to walk you through the details how we ended up doing. Something to keep in mind, I talked about earlier, there's only 5 products that we essentially produce, but those 5 products in our product catalog equates to 33,000 finished goods part numbers. Think about that for a second. 33,000 finished good part numbers that we're responsible for manufacturing out of our plant. And what we discovered is, okay, while you think that's daunting, when you blow up the bill of material on those finished goods part numbers, and on average, those 33,000 part numbers is about 50 line items on an exploded bill of material. So we're talking about really part numbers that exceed 1 million. And the reality of the matter is, with that level of complexity, how were we going to get the entire plant on WIP control, and how are we going to get to a new mode of operation where we can enjoy the benefits of all of the things that we discovered and we experienced with the first 2 demonstrations that we had done. So with that being said, I'm going to go ahead and turn it over to Wes. Wes is going to walk us through some of the details on how we got there. Okay?
Thank you, Pedro. All right. I'm going to rehash a few of those details as I tell the story. So Pedro talked about our product portfolio, and I like to put a face with the name. I've kind of condensed it down further into 3 categories. You can see the little triangle and the little box in red, and that's what a fitting is. Those are welded onto our customers' pipelines. Then in the middle, the orange box, is the valves, adapters, and housings section that Pedro talked about. And then at the top in the green box, we have machines, and we have 2 varieties of machines, tapping machines and plugging machines. So on the fittings, they're our simplest product that we make. They have 2 sub-assemblies, and then they're combined in one for a total of 15 to 20 components. And the middle portion, those are slightly more complicated, somewhere between 10 and 50 components. Typically, 2 sub-assemblies that are then welded together. And then our machines are where we get the crux of our variability and all of our sub-assemblies. They can range from 4 sub-assemblies all the way up to 10 or 12 as they grow in size. For all of these components, we range from 2-inch to 36-inch in size. I'm only telling you that so you understand that whenever Pedro talks about the 33,000 finished good part numbers that we have, it's because we offer them in such a large size envelope and in different types of markets, high pressure flow, low pressure flow. And so I'm laying this groundwork so you understand just how much variability we're dealing with. For those of you who've ran the SPS model, we don't even get a map out of our model. We have over 100,000 process steps in our models typically. So the plant that Pedro and I support, the plant that Pedro and I support is responsible for delivering these products to our customers and to our services department. And that plant has about 55 or 52 work centers. We have 5 cellular manufacturing centers, and we have 5 assembly cells. And I'm just laying the groundwork so that you understand further in the presentation why I'm telling you these things, and so you can see some of that. So with all of those different routes, that large diameter fitting demonstration that we did with factory physics is the closest thing we have to a dedicated line. If you look at all of our other routes, it's basically spaghetti across the entire plant. There is no streamlined approach. Everything goes everywhere. So as soon as we started to model the whole plant, because we needed to get the whole plant on WIP control using CONWIP, we ran into a problem because we have 33,000 finished good part numbers. So we were trying to wrap our head around how do we do this? And so we did an analysis called runners, repeaters, and strangers. And so we looked over the last 6 years and we said, what do we sell every week? What do we sell every month? What do we sell every quarter? Or what do we sell every year? And that's what you see here. In the green, we have our runners. Those are things we sell weekly. It only came out to 500 part numbers. And then we have our repeaters. Those are things we sell quarterly. That came up to another 700. And then what you see is our strangers. And we make a lot of strangers, 5,000. So we didn't want to run this through the model. Our models already take a long time to generate. So we looked at the revenue impact at the stranger level. Oh, I keep pressing the wrong button. So again, this is a little bubble chart of the same thing. You can see the big red, that is our strangers. That's the largest portion of part numbers that we observe. But our revenue clearly comes from our runners. That's what our customers need day in and day out. So this was unfeasible for us to try to wrap our minds around. So then we looked again at the strangers, and we did a Pareto, and we found that the 80%, that 10% of the part numbers make up 80% of the revenue we get from the strangers. And so we were able to rationalize this a little bit better by just taking that and that encapsulated 95% of our revenue across all of our part numbers. And so we used this result, which whittles us down to 1,800 part numbers. And this is where I get that number for 100,000 process steps. I actually had to call Chet and say, hey, my model's not running, what's going on? And it's basically, oh, you have too many process steps. We have to increase how many lines we have available. So we ran this model, and we found that for our plant, we had 9 bottlenecks. And we still haven't got to, it's still not easy to do yet. You know, we still haven't found a solution. We've just found where the problems are. So how are we gonna create CONWIP loops or implement WIP control in our factory around these 9 bottlenecks? I mentioned it was spaghetti, and that spaghetti goes everywhere. And so across these 9 bottlenecks, we could have the same routing that goes across all 9. And that's frequent. Those machines that do a lot, they do a lot. So we had to figure out how are we gonna do this. So we got together our production team, our planning team, and some of our other plant managers, and we were telling them, you know, we can do the model based on by different types, by different sizes, but every time we try to put a flow together, there's so much overlap, we were having a hard time. And one of our colleagues came up with an idea, and he called it the black box. We've since renamed it to a bottleneck hierarchy, because that's more descriptive of what it actually is. And so the concept here is you have 9 bottlenecks. Let's make the loops around the bottlenecks. And so basically how this works is all these routings are going everywhere, but we have different bottleneck rates for each machine. And so we've said, okay, which bottleneck has the slowest rate? Okay, we're gonna make that one the king. And so for all the routers that go through multiple bottlenecks, we're gonna not even consider it in these other product flows. This one bottleneck is gonna absorb all of them. And so that's how we started to rationalize that. So we had rank 1, rank 2, rank 3, and we had 1,800 parts, finished good parts, and so all their different routings, we were able to push them into these different loops according to this bottleneck hierarchy. And that's how we were able to create our CONWIP loops, our constant work in progress loops. And this approach worked very well. Everyone started to understand this because we have routes that go across so many different places. By doing this, we knew that we were able to control the WIP in a different way. Okay. Oh, so let me back up. So we implemented this in April of this year, and it was going remarkably well. In fact, in the the second week, on Monday, the second week of April, our plant manager came to us and he said, I don't really know what's going on. We've shipped twice as much revenue in the first week than we normally do in any month. And so obviously we're very ecstatic about that. But he doesn't know why it's going right. We should have recognized the red flag. So we were really pleased with the results, but around the third week of April, there were some tailwinds from the old mode of operation and the need for a certain amount of visibility that we hadn't necessarily gotten to with the new mode of operation. And because of that, some of the forces collided, and unfortunately, we reverted to the old mode of operation. And when we did that, we had to go into diagnostics mode and figured out what's going on. What did we miss? Why did this happen? And so we identified a vicious cycle. We spent the next 4 months examining the system and the current state and where we're at and saying, okay, so what went wrong? So we start with this. We have lots of expediting, and what we found too was that if you're familiar with MRP, we're firming almost every order that comes in. So we're saying we can do this project, and we're saying we can make these parts, and we'll put them into our system, and we'll lock our schedule almost 6 to 8 months out, which is unreasonable in a manufacturing environment, especially in a low volume, high mix environment. Yes, low volume, high mix. And what we also saw was because of that, we were releasing things far too soon. So our WIP was completely out of control. And so because of that, what happens is we end up getting excessive rescheduling. And when I say excessive rescheduling, I'm not talking about 1 or 2 reschedules here or there. I'm talking about order of magnitude of 150 reschedules per day of moving orders around. And when you do that, what you end up getting is you get excess and uncontrolled and stagnant WIP, which leads to the reduced ability to have capacity. You can't release anything else. You can't flow easily. Where are you going to put it? Everything's already on the floor. And this increases your cycle time because now the question becomes, what am I going to work on today? I have 50 things. Which one's the most important? They've all been rescheduled at least once. I don't know. What that does is it just increases your lead time. And you know what that means? If your lead time increases, you know we can probably beat that by releasing it earlier. So after a while, you get fed up. And so what that ends up doing, after a time delay, your customers stop ordering from you. They cancel their orders, which leads to more uncontrolled, stagnant excess WIP. Let's see. Yeah. So this is another little subsection that as you increase the amount of WIP that you have on the floor and you keep changing people's priorities, you run into quality issues, which degrades your ability to flow through the shop. And in the long term, what happens is everyone, your customer, your planners, and your sales folks, they start to lose faith in your ability to deliver, which then leads us back to more expediting. So the place we're at in our journey now is we've tasted the good wine. You know, we want this. We see that it can work. And so now we're tasked with how do we break this vicious cycle? And that's where we're heading next. We're starting to break this vicious cycle. I'll turn it back over to Pedro.
Thanks, Wes. Yeah, so where we are in the journey now is we've shared this vicious cycle as part of the diagnostic work that we did with all of the key stakeholders, and they all agree, right? When we walk them through it, does this make sense? Does this make sense? Yeah, I live that every single day. So they all agree that this is what's going on. However, despite everyone understanding that this is what's going on, it's the devil that they know, right? And so we're up against some of that. This is what people are comfortable with, living with this. And so now part of the journey for us is, okay, how do we get them comfortable being able to move back to getting the WIP control, getting those getting those CONWIP loops re-implemented. And what we found was that there's a change management component to this, and we've had to adopt a little bit of a change management strategy. And so what we ended up doing was we negotiated with the production planning group, and we said, hey, look, when it's time to go re-implement this, and we negotiated a date to turn it back on. It's going to be January 6th, so it's just a few weeks away. What we agreed that we would do is that we would not introduce the FISFO, first in system, first out. When we introduced it back in April, we had turned on the FISFO, the first in system, first out, and automatically what that did was it took all of the orders that were old, right? The oldie moldies all of a sudden came up to the top of the list and said, hey, I need attention. And then that started competing with other interests. And so what we did is we said, look, we'll give you the ability to be able to move a certain amount of things, but beyond a certain point, once it's released out onto the shop floor, you can't move things. You gotta follow the discipline. So we've given them the opportunity inside of our virtual queues before we release it into the system. They can move things around to their heart's delight. And so that seems to be well received. And so part of the story, stay tuned. But the plan is January 6th, and we're going to go ahead and turn it back on and move back in that direction. And hopefully by this time next year, we'll be able to share with you where we are on the journey. Okay? I think we're over a few minutes, but James, not sure if we wanted to tackle any Q&As or if we're up against a hard stop.
The stranger that you talk about, there are basically custom-made, they are not commodity items. I know for a fact because I'm in the oil and gas, so we work with some of your custom-made product. For those kind of product, you were talking about your stakeholder, have you involved your customers in managing these? Are you gonna, what are the type of conversation you're having with your customers?
So if I understood your question correctly, to what degree do we engage with the customers and have the discussion around the engineered to order type?
Yes, because I'm on the side of expediting.
Yes.
I'm the one expediting you.
Yes.
So what is the conversation you're having? Because I want my product, and I want to know that it's in the queue. You're gonna do it, and you're gonna favor me versus I work for BP versus Shell or Chevron.
Sure.
So I'm gonna be in your office every day calling you. So
that's an excellent question. Part of the strategy there. A couple of things. Number one is to the extent that we can start standardizing a lot of the engineered to order fittings is going to go a long way, because then in that particular case, we can introduce something called a late product differentiation. So we could put things in semi-finished good condition, strategic inventory points, so that we can compress the lead time. And that way, when the order comes in for the specific requirements, we can pull it out of a semi-finished goods condition and then take it all the way through the balance of the process and get it to the finished goods. So that's one of the strategies. The other thing is, to the extent that we can continue to work on building up our safety stock throughout the plant, is going to put us in a position where we can free up a lot of those work centers. So what we're trying to do really is trying to move towards selling the preponderance of the portfolio as much as we possibly can, either out of a straight out finished goods configuration or a semi-finished good configuration. I hope that answers your question.
Yeah, because neither of us wants inventory. So, and I'm trying to understand, for multiple reasons, none of us wants inventory, no? You don't want to keep the inventory. I don't want to keep the inventory. So it's all these on-time delivery.
Yeah. Anything you want to add?
But I'm trying to see how I can talk to manufacturer like you in terms of production system and say when and how to say, okay, I'm ready, you're ready, but I think you answered my question. Is the semi-finished product? That's where we need to operator and or customer and manufacturer we need to agree on.
Yeah, because there is always going to be some engineered to order. We can't get around that. But the key is to have those precious resources available to be able to handle those. And so to the extent that we can move to semi-finished or finished good, that's a big part of the strategy.
And if I can add something too, once we get the system up and operable as well, we'll be able to give you much more reliable dates.
Mm-hmm.
Cool.
Can I add something to that? I think you guys have a huge opportunity. Pedro, I would invite Sarah from BP down to your facility.
Yes, absolutely.
Absolutely.
March her in front of the Vice President of Sales and let her say, we want to look at this from a value stream perspective. I'm from BP. I could maintain your whole business for you, Mr. PE guy, but we would like to work together. It's extremely powerful, and we've seen many customers through the last couple decades have the customer come in with that request. And it's amazing how fast the executives flange up when one of the big customers show up, or even better, if they don't have all that customer's business.
Excellent point. We'll connect. We will definitely connect.
You might be the top sales guy once you leave.
So I think you reflect a little bit about a lesson learned. 4 months of forensics sounds scary to me. I don't know how long you spent modeling the system and deploying. But what would you do differently if you had to deploy this all over again and not have to do the forensics? I mean, did you involve operations in this modeling? I mean, I'm just really curious, what would you do differently so you would have one approach?
Well, we had a few unique things that happened during the journey. We had done, I think, a very good job at doing change management, but about a month before we were launched, we had some turnover. I think that was a hamper. That was something that was difficult. I think if that was one roadblock that we couldn't perceive was going to happen. But I think, earlier you guys were talking about biting off little pieces, and I think what I would have done differently is maybe I suggested we bite off a little smaller piece to go first. I think it was difficult to see, for me, from a systems perspective, you're in one system and we need to be in another system, and I couldn't see the bridge between the two systems. So I think what we did was we tried to jump into a new system rather than find that in between. That's probably what we would have done differently.
Yeah, I would add to that the vicious cycle that we mapped out, we probably could have gone on a discovery before we implemented and mapped out that vicious cycle beforehand, because what we discovered was that we were affecting what we thought was a change in a part of the system that was going to be sufficient to affect what we were looking for. And what we understood afterwards was that it was affecting a much larger system. And that was lost on us until after we mapped out the vicious cycle. That's when we learned, hey, wait a minute, we've got people inside of the organization who've got a vested interest in doing internal expediting, moving things around to jockey up to the front of the line. And so all of the disruptions that came along with that, we were not the wiser until afterwards. So.
One of the other things I think we can convey, and this comes from just the discussions that we actually had, and as he actually just pointed out, they were shipping products at an unseen levels in the last 18 months. That, I think, is an indication of performance from a product perspective. But it didn't meet the individual salesperson's need to be able to expedite their products to the system. And he actually talked about a case where the published lead time might be 3 weeks. And if we stick to the WIP, it comes out in 3 weeks. But sitting next to them, someone will be taking an order, and someone will be calling, can you give me in a week? And they will say, yes, I'll get it to you in a week, and try to force their stuff actually through the system, which would increase the WIP and so forth. So having to address that is what actually is taking them to deal with, not the technical aspect of the situation.
Yeah, good point, absolutely.
Yeah.
don't need the mic, but let's pretend that I do need the mic. So I think there is a win-win situation between what you guys are trying to do and your customers. I think the thing is to explain to your salespeople how to sell better your production system, and explain to. I've been in situation where your sales guys promise, and then it's a very difficult conversation escalate very quickly to the vice president of both companies being in a call, but. For me, the recommendation is to do a better job to explain your production system so that the customer can say, well, my production system works this way, your production system, where can we find the touching point, the win-win situation?
If I understand you correctly, I mean, the reason why you expedite today is because you're working under the fundamental understanding is that that's the way this production system works. I get my stuff when I expedite, right? Yeah.
So, and the fact that I have to pay expedite the day one from the get-go is because I know that I have to expedite your company or other
Yes.
companies. So I'm spending a lot of money because I know I'm not going to get it even from the promised timeline that you are going to give me. And also I'm going to give you a deadline. You don't know my deadline, but I give you a deadline that probably is 2-3 months before I actually need it because I know you're going to be late. So there is a better job at explaining your production system.
Agreed.
So it's really clear, the vicious cycle is bigger than that.
The issue cycle is bigger than that, yes.
Yes.
And hence the invitation to visit, I guess.
Definitely. No,
Yep. I look forward to connecting with you and keeping the discussion going.
Well, that was excellent. Thank you very much for sharing your experiences with us. And we look forward to having you come back and tell us
You bet.
the story.
Thank you all. Appreciate it. All righty.
Yeah.